Hello. Uh, Good afternoon, everyone. I am Shubhanu Haldar. So I am a PhD student at IIT Delhi. So I'll be taking the tutorial for this course. So, uh, so to start the session, today is the first day. So there is some logistical problem. So I'll be starting within a few minutes. Okay.
Okay, sir.
Yeah. So let's start our class. Okay. So this is the first week of our natural language processing class. So it will be better that if you guys introduce yourself. That why at least few of you. There are I can see there are 56 participants of this class. So it's not possible to hear from all of you, but I can really I am really I would like to listen from you guys that why you joined this course. So you know that you have already seen the NPTEL lectures of Professor Pawan. So you have already seen those lectures of week one. So I know that you have learned that what's the topic for the first class, why there is NLP and what is NLP, and why this course exists basically. So if you guys please unmute yourself one by one and can share about your thoughts that why you joined this class. So I have disabled the microphone, so anyone from you can start.
Hello.
Yes, yes.
Sir, I'm audible?
Yes, hi, hi Bhaskar. Yes, you are audible.
Sir, this is Bhaskar here. So I'm working as a assistant professor in Government First Grade College, KGF, Karnataka. Hello.
Okay, okay, great. I can hear you. Yes, please go
Yeah.
ahead. Hmm.
So I joined this course basically because I was quite interested in NLP, and I was planning of pursuing my research in this particular field. So I wanted to learn more about this particular topic.
Yeah.
I was more interested in this field. So I've joined this course, and parallelly I've joined another course on ML.
Okay.
machine learning.
Okay. Okay. Great.
And unfortunately, today what has happened is on the same day, same time, both the tutorials have been scheduled
Okay. Okay. Okay.
between 6 and 8.
Ah, okay.
So anyhow, I have requested the instructor there to record the session and share it with me. Sir, kindly, sincere request from my side is, next time one of the tutorials is scheduled, please just have a comparison with the ML sessions and please decide.
Yeah, so basically this session is decided by the NPTL team only. So this is not decided by me. Okay,
Oh.
so that's a gap between these two. So yeah, fine. I'll try to I'll try to forward your words. Okay. So anyone else
Yeah.
there?
Thank you.
Thank you, Bhaskar. Yeah. Anyone else there? So yes,
Hi, Subhan.
yeah, hi, please go ahead. Yeah.
Yeah, I myself Arun. So I have chosen this course since I'm working from the contact center background. So I work more on this the call center recording. So where there the transition is worked like speech to text and other thing, the bots, okay, the chat and chat bot, voice bot. So I would like to more deep into this. This is the first course in NPTL. So I'm
Yeah.
looking forward to learn more. Yeah.
Okay, great. Thanks for sharing, Arun. Yeah. So anyone else from student side? So we have got two responses from who are working professional. So you guys can please go ahead.
Hi,
Yeah. Hi, Raj. Yeah.
myself Rajpal. I'm construction manager in Siemens Limited. So just I joined this course to enhance my learning experience.
Yeah.
Actually, I'm interested in Chat GPT.
Okay. Great. Yeah.
So
So
from Chat GPT, I'm working like some articles, and so I joined this course.
yeah, so this is very necessary for me to know your dream and like to know what you want to learn from this course. Okay, so that's why I asked beforehand that some of you can unmute yourself and showed your interest. So why you wanted to join. So this course is not a course on ChatGPT. Okay, so basically let me introduce about this course to you. Okay, so there are two things. One is natural language processing and one is large language models. Okay, so as you know that this natural language processing is like deep understanding of broad language, how they are designed, how what is the implement and test system that process this natural language for the practical applications. So you will learn more about the grammars, how they are processed and all. I can so if you have an expectation of learning the chat gpt, uh, so I can say you one thing: this course is not on how you build a chat gpt model. this course is this course is designed and recorded before that era when ChatGPT came eventually. But don't get disheartened. So I know I teach these topics in IIT also. In IIT Delhi, I meet the BTech student. They have also the same kind of requirement. They also want to do research. They want to they are in a race. Okay, they have to write a research paper and all. So I know the requirements. Okay, so I decided to break this. We have a 2 hour session every week. Okay, so I have decided to break this session like first 1.5 hour. We will be learning about this course only. Whatever this course is NLP. This the NPTL whatever Professor Pawan Goel has is teaching you. What are the questions you can get from that course in if you give the last end semester exam, you will get a certificate there. So what kind of question you can expect, what kind of question you can expect in your assignment, how to solve the question in your assignment problem. So first 1.5 hour I will dedicate to solve that, because this is not a course on a large language model. But don't get disheartened. So last 30 minutes every day I will try to talk from my side that what is a language model and what is a large language model and how this chat gpt came into picture. Okay, so I decided to take this part of this language model into the last 30 minutes of our lecture, but as you are interested, so I will begin with that only. I will begin with that part only, then I will come back to the solving the question answer. So in this session, my motto is to I have some sample questions. Basically, they are previous year question from the previous year's course exam and the assignment questions only. So I will ask you to solve them. Then I will give you the solution. This way, the whole process will go on. But as you are interested, and I know that it is important to know the large language models. Okay, so I have my own plan for that rest 30 minute of our course. Okay, so today for today's lecture I will try to start from that there only. Okay, so yeah, so fine. So before as some of you has open up and told me already that why you have joined this course. Yes, definitely one is research aspect, from where we can start our research, that we will learn how the paper is how today's paper is growing, how what they are doing, how researcher in IIT or researcher in other industries, how they are writing the paper, how they are coming with a good model or a good solution in terms of research. We will look into that also. Okay, before that, can any student from there who are who are there in their college, so can anyone can anyone come up and tell me that why they are here? So there are 87 participants today. Yeah.
Hi, Subhanu.
Hi,
Sir.
hi. Yeah.
Hi, this is Akshay from Tamil Nadu. I am studying BE Computer Science first year.
Mm-hmm.
So I am not quite interested on the first part to join any courses on NPTL. But since my college professors forced me to do, I was searching a course to do just so I can move on from them. But I was quite intrigued when I saw natural language processing, because it is very essential, and it's the future, if I say so. So that's why I have joined, and I'm looking forward.
So one story, let me tell you. So
yeah.
So this Monday only. So this is Friday. This Monday only, one of my paper got accepted. So so it accepted in a conference called WWW. Okay. So this conference is called the Web conference. Okay. So this in 2000 or 1990s or 2000 up to 2010-15, it was a very good conference, because the conference is about how the internet has evolved. People people research about how can they do better in terms of internet connectivity, and how can they connect people better. Okay, but when I saw the importance of this conference, I found out that nowadays the importance of this conference is going down. Now there are other conference which is like NeurIPS or AAAI or ICML. These types of machine learning conference are in a new trend. Okay, so this LLM is its peak now. Okay, someday it will saturate, but before that you have to know the basics. So this course is about the basics only. So let's begin our lecture today. Okay, so where my first goal is where this LLM is in AI, artificial intelligence landscape. Okay, and where there is NLP. Okay, so you know that there is artificial intelligence, which is the systems with human like intelligence. Then we have machine learning, where we have developed some algorithms like which learn some rule automatically from data. So what are those algorithms like decision tree, random forest, support vector machine. They are the kind of algorithm which we developed, which we call the machine learning algorithms. Then it comes to deep learning. Okay, now this deep learning is basically the machine learning with neural network consisting of many layers. Okay, so you know the neurons. There is a neurons. There are neurons. You need a huge amount of data. Then you can feed the data into the neural network and it will give you a output. So that's a deep learning architecture. Now there is a large language model. So before this large language model, we have a concept called NLP, which is natural language processing. So this natural language processing came from the father of this NLP is Chomsky. So we have a subject we read in our BTech level course, which is called automata theory. Okay, there you learn about grammar, your parse tree. So that is developed by Chomsky. So he is the father of NLP also. So why this is the case? Because it is called natural language. So you pupil what pupil talks naturally. So what I am talking to you, I am talking from my heart. Okay, I am not looking into any grammar. I am talking from my heart. Maybe I can in my English speaking, I can make a mistake. I can make a grammatical mistake, or I can make I can make a mistake from aspect of pronouns. Okay, so I can make a mistake. I am not following any grammar. Okay, what I am telling you, I am telling you from my heart. Okay, so but you see the language like Python or C++, it always follows a grammar. Okay, so this is the difference between natural language and this is the difference between natural language and other languages. Okay, like our programming languages, which follows the grammar. Fine. Now to process this natural language, we have many tasks like so first the oldest task was the machine translation, like the translation part, like from English to Hindi or English to French or French to English, like this kind of task was the most historical task that was solved using NLP. So here people are using this deep learning to solve the NLP problems, solve the NLP goals. Before this large language model comes into the picture, people use this deep learning, the LSTM, RNN, CNN, this kind of approach they are applying to the NLP problem. So NLP is a type of task. So like NLP, I personally work in finance, AI in finance. So in finance, I use deep learning, I use large language models, this type of. So there is healthcare. Okay, so in healthcare system, you use large language model to design a chatbot or to design or you can use the deep learning to predict cancer or not. So this kind of work is there. So these are the tools, this machine learning, deep learning, large language models, generative AI, where when the diffusion came into the picture, the unit diffusion, when it came into the picture, then it evolves this technology evolves. So you get more and more tools. And where will you apply the tools? This is the sectors in healthcare, in finance, in NLP. So these are the sectors where you will apply your models. So is this thing clear? I think this is clear. So now I'll come to that. What is the history of this NLP? So it is very important to see that where we stand now. Okay, so you can see that in 1966 there were this is ELISA. This is developed by MIT Watson Lab. Then in 1972, so 1966, just after we get the independence. So then 1972, then 1997 our LSTM came. So we heard a lot about the LSTM and CNN and RNN. So they are not a recent model. They are very old model. So what people are doing, researcher are changing this model. So we have LSTM, then they are implementing bidirectional LSTM. Then they are implementing some LSTM with some by changing their some of the gates. They have invented the GRU, that is called gated recurrent unit. Then so this is kind of research that is going on. So in this course I'll try to give you a flavor that how the research is going, basically how people is writing a paper out of using this technique, and on using this machine learning technique and deep learning technique. They are implementing the they are basically applying this technique on the LLMs. Okay, fine. So then 1999 to 2000, this NVIDIA, their GPU came. Their GPU is basically for graphics processing unit. They can process a large amount of data, and they collaborated with Google, and they came into the picture. Then there was in 2000, IBM was working to release their statistical machine learning machine translation system. Basically, all of this is based on the statistical learning or statistical ML. In this course, we will learn a lot about this statistical machine learning thing, that how they evolved, how this IBM came up with this model. Okay, we'll learn a lot about this. Then now our Facebook came into the picture in 2010. Like that, Facebook came into the market, and their Facebook AI research is created. They has the data. Okay, Facebook has the better thing that they has the data. Okay, that's why they came up with the research lab, and they started working. And then your Google also started its research on 2014-15 on NLP. And behind all of them, there is one company called OpenAI, which is founded on 2015 and 16, between 2015 and 16. So this OpenAI is the parent company of the ChatGPT. Okay. So in 2016 and 17, the Stanford also, many research groups is coming with their own approach to they are developing the new NLP model. And after 2017, this thing called transformer, there is a paper called Attention is All You Need. When this paper came, the rest is history. The ChatGPT evolved. Okay. So then now everyone has forgot what are the statistical machine learning. Okay. But remember, our course, this NLP course, is not focused on this after this 2017. It is more focused on how the NLP evolved. It is so. I personally gave many interview in many companies. So it's not like that ki you will only learn about large language model. It is very important you to learn the natural, how this natural language processing evolves. If you want to apply your machine learning technique on some topic, you have to have a good in-depth knowledge of that sector. Okay, I have knowledge about financial sector. I can apply any technique on that sector. Okay, so if you want to apply your knowledge of machine learning and deep learning and this generative AI, then you can invent anything. You have to have the knowledge on the NLP, so that you can apply this technique on the NLP. When these two things will collaborate, you will come up with a research paper definitely. Okay, so now so now we'll talk about the post transformer era. So which is also called the LLM race. So this is after 2017. So I know this is nowhere from your course. Like if you have seen the video lectures, this is nowhere from your course lecture. But I personally think that this topic should known to you. So you should know the things that where our research stands now, most researchers are doing, most of the like what are the most pioneering tasks people are doing. Okay, so we have to know this, because the there is a race, so you have to be very in the first line of that race, otherwise you will fail definitely. Okay, otherwise you can survive more number of days. So that's why it's very important to know the NLP, and to also to know this post transformer era, how this large language model evolves. So this is out of, I am again saying that this is out of the course of NLP, which is you have taken CS25, CS51, okay, NOC25 CS51. This is not any, this is not from that chapter, but I am telling you because I love to, I love to share. Okay, just for that only. So every day for 30 minutes we will try to share, I will try to share my thoughts. So as this is a first class, this is an introductory class, I will go long with this topic and I'll go short with the with our assignment solution and all. Okay, that can be done quickly. I'll tell you definitely. Okay, so is it interesting? So should I go ahead? Can anyone please comment out? Can anyone turn on their microphone and tell me? Yeah. Yeah, thank you, thanks a lot. Yeah. Okay, so let's go ahead. Okay, fine, thanks. Yeah. Let's start from, so for what we have seen that from 2017 this transformer model came. So we have to, we should know that what are the papers. So if you search in, can you please you please, anyone, I am telling to any one of you, please read what I am saying. Okay, so if you lose this moment, you can really rewind this from the YouTube lectures, but there is a thing that you can, that's why there is a live class, live interaction session. So any of this document you can find it out, I'll share the link, everything you will get it. But the main thing is here is the listening. Okay, so yeah, so I'll share everything, don't worry. Yeah, so you'll get the notification from the NPTEL team. Okay, so now come back to our topic that we have very I am a PhD scholar only. Okay, so I am very proud that some of the professors has joined this call to listen to me. So thanks to everyone for joining this. I don't know that how much can I how much can I share from my knowledge, my understanding, so that it benefits you. But I'll try my best, sir. So what I am thinking that to share some of the papers with you. Like this attention is all you need paper. So this is the first paper from the transform, which introduces the transformers. Okay, so this is done by Google researcher. Okay, so the funny fact is that there are 8 researcher you can see. So this Ashish Baswani, so he's a Indian, so he was the main lead of this research paper. So to read this paper, so what are these things? So to the very young chaps in our room who are in BTech first year, or they are doing BTech, or who don't about research paper, what if you are more curious about this, search this name on Google, that attention is all you need paper. So you will get a link from archive or anywhere to download this paper, then read this paper. So these are the papers which introduces this ChatGPT. Okay, or rather this introduces the transformer architecture. So in 2017 they came up with this paper, attention is all you need, where the transformers is first introduced. Okay, so the funny fact is that who wrote this paper, this 8 pupil, no one is currently working with Google. Okay, now they all left Google. Okay, and they and the thing is they all started their own startup. Okay, now in 2018 another paper came which is called BART, pre-training deep bidirectional transformer call language understanding. So why this paper came? So in this in this, so this transformer is the backbone of our ChatGPT model. Okay, fine. So yeah, so this transformer has two things. One is called encoder, another is called decoder. Okay, so first what you do, that you give some data to this encoder part. Okay, so which data? So data you have. So suppose you have a call center. So I'm giving a very overview. This is nowhere touches the implementational details. So their implementation should be very different from what I am saying. Okay, but this is the idea, this is the overview. If you implement it, you have to change something, and if the core idea is the same. So suppose you are a manager of call center or the chat center. You have so many chats, like people are chatting, like in Zomato. Suppose our Zomato order is late, we chat with the Zomato bot that is, hi Zomato, where is my order, please hurry up, okay, I am very hungry. Okay, so this kind of conversation is going on, and you fed this. So previously you have human to interact with the customer. So yeah, so you fed this chat into the encoder model. Okay, and your encoder model do some processing. Okay, then your encoder model will pass something to this decoder. Fine. Now what happened, this, you have encoded all your input. Okay, now what your decoder will do, now the live thing came, that now you are chatting live, so that you are giving input that where is my order. Okay, so now your model is trained. Encoder, in using encoder, your model is trained. Now you want to use your model, you want to use ChatGPT. So now the live thing will happen, because this chat, you have a huge number of chat. Okay, so you have a huge number of data. So to process this huge number of data, you need time. Okay, so this training of this encoder thing needs a long time. Okay, and a huge computational resource. So that's why your model is trained, and now you are doing the live chatting. Now you will pass your data into the decoder, then your decoder will do some operation with this data, and some, so this is the input from the live chat, and this is the input from the encoder model, and it will give you a output that where is my order, your order is near to your home. Okay, near to your location. Yeah, fine. So this is the kind of encoder decoder architecture. So in 2018, how the research evolved? See, so I am talking about how the research is evolved. So people is saying that pre-training deep bidirectional transformer for language understanding. So they are pre-training this model, pre-training this encoder. Basically, you want to use it at 12 a.m. So I am starting my pre-training and saving this, whatever there is a output of this encoder. I'll be saving this, and I'll be using this decoder as a live. Okay, so this is the, so previously what happened in transformer, it is doing the same thing, like it is, the chat is coming, the encoder is encoding, you are also giving your live input, and like same time it is happening, encoding and decoding is happening. So it takes a lot of time. So Google people came up with the thing that yes, pre-train this encoding model, and we can save it, the pre-trained encoder, and then use the decoder model. Okay, so this is how the research works. Basically, this is how they have changed the things. So one thing I will say, that this paper come in 2018. So this encoder in our transformer is called BART, and the decoder in our transformer called GPT. Okay, so from where the ChatGPT, this name came. Okay, is it clear to everyone? Okay, so now I will take some questions. So please, I'll give you the microphone access. See, someone is raising their hands. So please, can you open up? Like, what do you want to say? Please tell me. I can't hear you. Anybody? If anyone has any question, please tell me. Yeah. So Panjala Kavita. So you have raised your hand. Do you have any question? So am I audible to everyone?
Yes, sir, you are audible.
Okay. Yeah. So anyone has any question? So any doubt or like, are you liking this session, or should I go back to our NLP course? Like,
Sir, some two questions are posted in the chat.
okay. I didn't look into it. Yeah. Sorry. Yeah. Can you, what will be input in the decoder in time of inference? So we'll come to it later. Okay. I am Shobhag Gopal. So I am giving you a very like, in today's class I am giving you a overview only. Okay, I'll not take this question today. It is like little in depth. Today we'll see the history. Definitely I have promised you that we have 12 classes, so every day I will come up with these topics. Okay, that what are the things, how the language model is evolving. So I'll come up with the things, then I will take your question definitely. So today I will not answer this. Okay, which will basically waste my time and waste your times also. Yeah, I'll definitely answer you. I'll remember it. Yeah. So now 2018 OpenAI, it started pushing their frontier. So they came up with a paper that improving language understanding by generative pre-training. So are you seeing this word that called pre-training? So in BART paper also there is called pre-training. Okay. So these pupil, can you? Yeah, I'll give example NLP in finance later. So let's go ahead with our whatever we I have taught. Yeah. Now this BART, you have see that this BART pre-training, this word is here in second paper. This is the first paper of AI. So you would remember this person. So he is the founder of OpenAI. Okay. So here see also that this pre-training came. So pupil has understood that that encoder is something which we can pre-train and save it. So in 2018 this is called the GPT of the GPT paper. Okay, this is the best GPT paper. So we are now using chat GPT 3 or 4 maybe. So basically this GPT model is basically they are polishing in their way, and they are coming up with a new paper. Now in 2019 GPT-2 came, which is called language models are unsupervised multitask learner. So where they have increased their parameter size. They have done some minimal change, only some in terms of model. They have only added layer norms. Okay, previously they have used batch norm, now they have added this layer norm and modified some weight initialization. So previously they used random weight initialization, now they have used some statistical weight initialization, and they have also increased the context length. They have increased it to 512 to 1024 tokens. And so as you are a very beginner of NLP, so you really don't know tokens. So that's why you have to learn the NLP course to know this token. Okay, then you can write a paper like this. Then you can make a pioneer thing. Yeah. Now this paper came that the multitask learner. So what kind of tasks they can learn? They can in GPT-2 they can do reading comprehension, they can do translation, they can do summarization, they can do question answering. So these are the all tasks of NLP. And if you don't know NLP, you can't you never come up in your mind, you can't come up with this kind of approaches, so that you can solve your you can apply your deep learning process to this natural language processing, or to this specific task. Okay, now what was Google developing parallelly? So like our Sundar Pichai, was he sitting ideally? No. So in 2019 they came up with a paper called T5. So this is called T5, which is called text to text transformer, which is a similar or broader goal of converting all text based language problems into a text to text format. So there is no speech, or there is nothing. So it is only text to text format. They use the encoder decoder architecture. the pre-training strategy differs from the GPT model, and strategy more similar to BART model. Okay, so we will see what the thing is. Yeah. So we'll see what the thing is. So are you getting the idea that what is my intention here to introduce you these papers? My intention here is like, who are the professors, who are the researcher here? They can look at this paper and one by one, and they can understand that yes, this is how the 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 industry has evolved. Okay, this is what the architecture is used. You can see this encoder decoder architecture. You have to know about this encoder decoder architecture. So this is my only goal here. Okay, now okay, we are comparing Google and OpenAI, but where is our Facebook? Okay, so yes, they came up with this Roberta in 2019. They replicate the study of BART pre-training. Okay, now they have found that BART was significantly under trained. Okay, so this paper was they came up with 2019, but they are trying and submitting their paper in many conferences, but they were rejected. No one is listening to them. Okay, yeah. So this is kind of thing that was going on there. But now they also came up into the picture. So the thing is that this encoder decoder model has many parameters. So, and they are learned with, they are fused with so many text and data. So that's why they are not trained well. So the weights updates are not done pretty well. Okay, so people are now seeing that is these models are very big. You really cannot train this model in your laptop. So we have a huge server in IIT Delhi. We are really we fail to run this model into our server. Okay, so these companies are very giant. They are giant. Okay, so they have many sources of their resources, and they have huge computational setup, so that they only can run this kind of model. We really can do this. So that's why these people came up to scaling up this model, so that to scale up means to regulate the parameters so that the model perform well. And also they came up with some student teacher model, so that like can it be used in the mobile devices or not. Okay, so this type of paper came into the picture. Okay, now in 2019 this Meta also came up with his Roberta and cross-lingual language model pre-training, which is called XLM. Okay, so you can look into the paper later and see that what they are doing. I have tried to jot it down that what are the main thing they are doing in one two word. Okay, now in 2021 and 22, in COVID era, like in 2020, people were sitting in their home, and they were not really sitting. So in 2021 and 22 there is a boom. Okay, when the ChatGPT came into the picture, Microsoft with Nvidia, they came up with their Megatron Turing NLG, the Gopher from the Google DeepMind, and there is Lambda from Google DeepMind. This is called CodeGen. This company came up with their model, which is only it only give you a code. Okay, this is to generate the code and all. Then OpenAI came into the picture. They launched the ChatGPT, and also Google AI also has some papers. Now what happens that in 2022 these papers are coming, like people are publishing these papers, and this OPT Meta also promotes their open sourcing. That yes, open sourcing mean whatever model you are implementing a code, then you open source it. That means that you you say that yes, this is my code, I am giving you the code, you can also integrate your code into your model and run it whatever you want to do. And you see that there are 125 million to 175 billion parameter, so that it is not very easy to open source it and run into your laptop. Okay, so now there is a boom on November 30, 2022 when the ChatGPT came into the picture. So the OpenAI played a very big game. So so what they did, that they stopped open sourcing. They are not sharing their code. Okay, so in 2022 when they launched ChatGPT, they are not publishing any paper in any conference. Okay, so they have stopped sharing their code. Fine. Now they are in the business. What the business? They have developed the model. Now they need the data. Google, Facebook had the data. Google, Facebook had a lot of data. But when this ChatGPT model came, then people are using it. People is giving the ChatGPT the data, and ChatGPT is training more and more. So basically, we are giving, we have grown up this ChatGPT. Okay, so when you are searching something, you are giving the data to ChatGPT model, and you are basically giving the data, and you are basically want to grow up this company into a giant. In 2023, there is a rapid change of in this ChatGPT model, in these GPT models, where 2023 Google release is Bard, then like in February Google release is Bard, but now if you search on web what is Bard, you can't find out, because in 2023, like within 10 months only, Google has removed its product and it has introduced a new product called Gemini. Now if you search in Google, you will find the Gemini, which was launched in December 2023. And there is Meta. It has launched is Llama, which you use in your WhatsApp. So in WhatsApp you can chat with a bot. Okay, so here the Llama model is used. Okay, so then there is GPT-4 came into the picture in March 2023, which is equally capable of like doing the multitasking, question answering, and giving you a piece of Python code, anything it can do. And then Mistral AI. So this is a very good company. I really follow this company. Basically, they are coming up with a thing that this Mistral 7B. This company. So this Google, Facebook, and OpenAI, they are all big companies. They have million. They become a giant. So that's why they have a lot of money, and they have a lot of resources. They can do any computation. Okay. Now now we have some small scale company. Okay. So we have some B2B companies also. So which don't want that much of performance, but we don't have that much of budget also. So what to do then? So then this Mistral AI came into the picture, and they are basically like squeezing the model, and they are basically reducing the parameter. They are basically doing the scaling of this model, and doing the research. Yeah. So this was the history of our ChatGPT. So I think like this story helps some of you to bring the interest into this course. Now I'll show you a newspaper. So you definitely remember this, that before the US election, this is the first page of the Times of India, that Donald Trump's date. So what do you think, that this is a mistake, or what is this? Like, is it correct? First of all, is it correct, or why is it correct that is there a missing of apostrophe s, that Donald Trump's date, or what is this? Is it correct? So what do you think? Can anybody tell me? Speak out, please. Like it should be a it should not be a like it should be a one-to-one class, so that if anyone, can you please tell me that how the story I told you, how was that, and also is this a correct sentence or not? Yeah, please go ahead.
So the sentence is correct.
Yeah, how why?
Trumps is used as a verb, I believe, here.
Or this verb
it is playing. it is being played with words here. It is more about Donald Torrim's The Death Attack. That is what it speaks about.
Yeah. So yeah, so this is yeah, so this is like the trump card when we play the card game. So this is like the trump card. So so that's why it's called that Donald Trump's date. It's basically Trump card the date. Yeah, please, anyone else, please go ahead. I'm really eager to listen to you. Yeah, please. Aparna, you are saying that, can we say that understanding NLP concept is prerequisite to understand LLMs? Uh, Not like that, but it's 80% recommended that you do this NLP course before understanding the LLMs. You will not have a problem there, but if you want to go deep and deeper, it's important to do you this course, this NLP course. Yeah. Anyone else? Can you please speak up? We have like around 100 students here. So I have taught in Nptel. I have taught previously. I have taught the data structure and algorithm, then operating system. I have not attracted so many participants in any of these course. I'm feeling very lucky here. Yeah. Please, anyone, go ahead. Please open up. Unmute yourself and tell me that how you like the story. Did you know the story previously, or how you like the story? Is it a helpful one for you? And anything else? So that I'll also get a break. So I am also talking over 1 hour. So please, anyone. Okay, thanks a lot. Yeah. So okay, let me finish this topic first. So so we have so now we human can understand that yes, this term is used as a verb. So this is used as a verb. So that's why we that's why but this is a problem to problem for the machine to understand that this is the correct word or not. Okay, so and in human language there are 6500 languages are there, uh, where people, there are 6500 languages are there. So to understand all of this language is not a easy task. And also the human language, more than 19,500 mother tongues spoken within India only. So we have total 65,000 in whole world, and 19 among that 19,500 mother tongues are there in India. So I am a Bengali, so I know that in Bengali, if you go from one part of Bengal to other part of Bengal or Bangladesh, there are many dialects are there. So you really can't understand their dialects. I don't know. So there is a call in there is a place in Bangladesh called Sylhet. So you will not, you will, so as a Bengali, as a resident of Kolkata, you will never understand their language, but they are saying Bengali. Okay, now like this, that the real reason that why NLP is hard, that Virat Kohli was on fire last night. He totally destroyed the other team. So that mean that Virat Kohli is burning, like he is on fire, like he is standing on fire, or what? Yeah. So now what are the NLP layers? The NLP layers are under these are the NLP layers. So it is called the morphology, part of speech tagging, chunking, parsing, semantics, pragmatics, and discourse. Okay, so this processing of this language happens in layers. So first we will do the morphology, which will say you the study of word structure, how they are formed and their relationship to other words in the same language. And then we will do the parts of speech tagging. That means that the grammatical classes and all, how the grammatical class of a word is. Then we have chunking. That means that grouping of meaningful phrases. Uh, the, where we identify the recursive or non-recursive phrases, basically that means that noun, verb, etc. Then we have parsing, that means that validate the grammatical structure of the sentence using a parse tree, and like this. So these three, parsing, chunking, and POS tagging, this is called the syntax or the syntactical analysis. Then we have semantics, semantical analysis, and premantics and discourse. In semantics is concerned with the meaning of word and how to combine word into meaningful phrases and sentence. Okay, and pragmatics is a negotiation of meaning between speaker and listener, like negotiation of word meaning, that so can you please so if you have someone beside you, can you please ask him that, can you please pass the bottle? So what do? Will you pass the bottle or will you say yes? So will you just pass the bottle? Na, you will not say that yes. So this is like, this is called pragmatics, like negotiation of meaning between speaker and the listener. So and another is discourse, that means that processing of sequence of sentences. Okay, so this is the most upper level of NLP layers. So why is NLP hard? So you know that why is NLP hard? Yeah. So in NLP we have three things that which is called the NLP Trinity. That means that we have problem, we have language, and we have algorithm. Okay. So you use this algorithm dot HMM, hidden Markov model, or CRF, or you use this algorithm to solve this problem for this language. Okay. So another thing is that like in Hindi, you know that there is a pronoun of so pronoun has a gender. Okay. So like मैं जाऊंगा, मैं खाऊंगा, मैं खाऊंगी, मैं जाऊंगी. So I used to have a lot of problem to learn this. I really know that learning this pronoun was very difficult for me when I first came to Delhi. Okay, because in our language we don't have a pronoun like this. Okay, we don't have a gender of these pronouns. Okay, so that's why our Hindi is a very rich language. Like it's called it's very syntactically or semantically very rich language. Okay, so this is the NLP Trinity, where we use this algorithm to solve this problem on this language. Okay, fine. So this was the introduction of today's class. I think I have tried to finish this within time, within 1 hour. Then we will be starting solving some questions. So let me yeah. So let us so I think this was helpful for you. So this was an extra session. So this is not related to our course, but this is beyond of our course, that what can we see beyond of our course, beyond of this NLP. Now come back to our course, that what is called that this thing, that we are more we will be more involved in solving these questions. Okay, so what I suggest you to solve these questions by yourself, and please type your answer in the chat box, so that I can see that what the progress of you. And then then I'll definitely solve this question for you. So you take 2 minutes to solve this question and write your answer in the chat box, please. So there is no WhatsApp group for this lecture. Yeah. The document will be shared, and so Srikantha, you are not getting the assignment. You are getting the assignment you please mail to the NPTL. I also don't know from where you can access the class. I have different thing to access the class, but from a student perspective, I really don't know. Yeah, so many of you has answered that yes, one is correct. Yeah, so see, yeah, so 14 and 13 is the answer, because that here the word I is repeated 2 times, so type count is 1 less than the token count. So I think who uh, yes, will, yes, recording of this session will be provided. You will get a YouTube link in some days. Okay, so not instantly, but I have to upload that, so it will take some time for me. Okay, so it definitely will, you will get the recording, but it will take some time. Yeah, great. So now the thing is that yes, so what are the type and what are the tokens, what is the type token ratio? Yeah, so now here, so some of you has really answered it. I really appreciate you that you answered it. And I think you have seen the lecture videos of Professor Pawan Goel in NPTL. So how to solve this question? So the question is about, in this sentence, in Mumbai I took my hat off but I can't put it back on. Total number of word tokens and word types. Okay, I'll take a 1 minute break. Okay, so I'll come back. Yes, so in this sentence, so what is token and what is type? So our we know that if the thing is that a concept is called a type. Okay, and instance of a concept, it is called the token. Okay, so our type is always unique and our token is not unique. Okay, so that's why, so first here I need I need tokens and then word type. So you can see in solution that here the word I is replaced 2 times, so type count is 1 less than the token count. Okay, so this is the type. So this means the unique word, number of unique word. So here I and I are repeated, so that's why 14 and 13. So 14 13 unique word and 14 if I include I. So that's how I have calculated this. Okay, great. Yeah, fine. So can you please solve it? Yeah, so some of you have answered it 4:1 or 1:4. Okay, let's see. So it is saying that let the rank of two word W1 and W2 in a corpus be 400 and 100, okay, respectively. So like yeah, 400 and 100. So W1 400 and W2 100. Okay, so this is the rank of two word. Okay, now let M1 and M2 represent the number of meaning of W1 and W2 respectively. The ratio of M1 is to M2 is, okay, so that means M1 and M2 represent the number of meaning of W1 and W2. Okay, so how this will be solved? So now the thing is that we have already we have already seen some laws of like Jeeves law. Okay, so so who are not aware about this what we are talking about now? So previously I was talking about a story only. Okay, so that required no prerequisite or pre knowledge for you. But here what I am saying, that this required that you read the you read the lecture videos and come in the class so that you can solve it and you know the context. Okay, so it's only a 2 hour video lecture, so like so you 2 hour each week you really can do it. Okay, so this is from where I am talking about. Okay, so now fine, let's go ahead. So there is a law called Jeeves law. Okay, so what this Jeeves law says, that it first in Jeeves law we first count the frequency of each word type, then we list the each word type in decreasing order of their frequency. Okay, now in the first rule of Jeeves law was f is equal to root over 1 by n r, where from where we got that f is equal to r into k. Okay, so now also that we got that a by n is equal to a by r. So like Professor Pawan has solved all of these things in his lecture. So so here from if, and also this is the so basically what I want to say that let's do this like this. So if proportional to 1 by r was the law 1. Gibbs has also another law which says m means the meaning, the number of meaning is proportional to root over of f. So f means frequency, r means rank. Okay, so frequency means how many times, rank mean you rank them. So what I am saying, what Gibbs law says, that count the frequency of each word type. Okay, that means how many times it occurs in that corpus or in that passage you are referring to. Then what you do, that list, then list word type in decreasing order of their frequency. Got it? So you will be like in decreasing order, you will be listed to of their frequency. Okay, then you have this another law, that this meaning, number of meaning is proportional to root over of frequency. and and so that it comes up, if you this is the law 2, if you combine this comes that m proportional to 1 by r. So I am basically replacing f with r. Okay, now what happens, you got the formula m proportional to 1 by r. So that's why the m1 by m2 is equal to, so root over r2. Okay, that was 1 by r, 1 by root r. So that's why 1 by r2 into 1 by r1. So are you getting, this was 1 by r, that's why it is inverting and it is becoming f of 1 by r2 into 1 by r1. So that's why square root of 100 and square root of 400 is equal to 1:2. So 1:2 is the right answer. Devanshu Das and Bhaskar gave the correct answer. Yeah. So and Onurupa Maiti. Yeah. And thanks all of them who has gave the correct answer. Yeah, so this was the concept, and I think yeah, you see the lecture, you will get the idea. Now the question is that what is the valid range of token type ratio of any text corpus? So to who are wondering that from where these questions are coming, and I am really not here to again repeat you the theory and all, because I have decided that last 30 minutes I will tell about the recent advancement, as I told today about the large language models. In the subsequent classes, I will try to come up with the transformer architecture, and how these decoder models are working, how. So basically from I'll come up with the LSTM, then transformer architecture, so that you understand. And also, like, one thing I forgot really, so the slides and all, so the credit goes to Professor Tanmay Chakraborty of IIT Delhi, who is a professor in our electrical engineering department. So he is a really nice professor. He has also written a book on large language model. You can check it out. Yeah. So the all the so I have done his course, so all the all the slide credits goes to him only. Okay. So that's what. Yeah. So this is the thing. And yeah, so in this question answering session where we are solving the question, I will not be repeating this. I will not be repeating the theory again and again. So yeah, so this is the thing. So you have to solve the question, and so this is a like practice session only. You solve the question, and also like ask me that what this the question is about. I'll try to uh, I'll try to, in every question I'll try to give you the background of the theory as I am giving. Okay. Now in this question, what is the valid range of type token ratio of any text corpus? Okay. So what is the type token ratio? The type token ratio is basically how often a new word coming in the text. Okay. So TTR, which is called type token ratio, we call is TTR. That indicates how often a new word coming in the text. Okay, I think in the lecture, Professor Pawan has also talked about that in which kind of text your type token ratio is high and where the type token ratio is less. That we have many types of text, like we can have a news, we can have a news article, we can have a research paper. Okay, we can have a conversation, like some people will be using this in their chat bots, so they must have the data as of a conversation. Okay. So yeah, so they can have the conversation. Or what else, we have a book. Okay, a story book or any book kind of thing. Yeah. So everywhere the type token ratio is different. In I think so what is the range of this type token ratio? Yeah. So options are 0 1 0 1 minus 1 1 0 2 plus infinity. Yeah. So can you, so this is calculated as basically type by token. Okay. And also I have said that type is number of unique words and token is number of non-unique words. Okay. So our answer is 1. Okay. 0 1 excluding 0. Basically why that number of unique word of type is less than total number of token in text, and both are greater. Okay. So we have also seen an example of 14 is to 13. So the number of unique word is always less than the total number of token in the text. Okay. So that's why, so if you divide it like 14 is to 13. Okay. So like 13 by 14. So this was type and this was token. Yeah. So sorry, this was token and this was type. So if you give type 13 by 14, always you will give less than 1. Okay, because maximum you can have 14 by 14, which is basically, if in this sentence, if this was the sentence, so I is this was the sentence. In Mumbai, I took my hat off, but I can't put it back on. So if instead of I could have written, I have removed I, and I could have written we. Then we have 14 type and 14 tokens. Like we have 14 unique words: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Got it? Got the idea? So 14 unique word, 14 type, and 14 token. So that's why so 14, which is equal to 1 is the maximum number, and it can't never be less than 0. So, and also it can't never be 0, so that's why TTR belongs to 0, 1 excluding 0. Fine. So let's see option 1, who have given the correct, most of them has given the correct option. Yeah, thanks for engaging yourself. Can we just visit the previous questions of Jeeves law? Yes, why not? Yes, we can visit. This is the question of Bhaskar HS. Yeah. So this was the law 1, F proportional to 1 by R. So frequency. So this is what is F. F is the frequency of word. And what is this? This is the rank of word. So how this is calculated? So basically, this is calculated using that word frequency and frequency of frequency. Okay, so you please refer to the video 1. That frequency mean how many time I am trying to so Bhaskar, I am giving you the thing, that I am giving you the overview. But if you I don't have a slide, I don't have a corpus, I don't have an example, but in my word I am trying to solve your problem. I'm trying to explain you that you have given a passage or paragraph. So there some words are coming, so you have the frequency, that how many times maybe biscuit came into the passage, how many times zoo came into the passage. So they are rare words. So how many times tea or coffee came into your passage. So you have a very big corpus of dictionary. So there you are basically eventually calculating the frequency of the word. So that's why you are calculating the number of times it appears in your word. Okay, so that is called word frequency. So, and then you are calculating the, so basically there are also some unique words. Okay, so how many times this unique word appeared into the picture. So this kind of thing, that is called word frequency and frequency of frequency. You rank them by decreasing order. Then the first law says your word frequency is proportional to 1 by root r. And then there is another thing, that m proportional to root over of f. That means that the meaning, how the meaning is changing. Like we have two things, like begin, start. Okay, so begin and start has similar meaning. So that's why m and root f, m is so how many, so it is basically equivalent to number of frequency it appears. So m is proportional to root f. So these are the two law. If I combine these two law, it becomes m proportional to 1 by r. Okay, from here I am basically replacing f with 1 by root r. Then that's why m proportional to 1 by root r. So that's why m1 proportional to 1 by r1 and m2 proportional to 1 by root r2. So if you combine them, you will get m1 m2 is equal to, this is like the 1 by root over r1 by 1 by root over r2. That become root over r2 by r1. Got it? So I think it is clear. Okay, fine. Raza Ali. Okay. Yeah, please. I have given you the permission. Please go ahead.
No. The doubt that I had with this particular question was.
So please, anyone,
sorry.
one by one. Raza Ali, can you please mute yourself while
Yeah, please.
I listen to you. Yeah.
So, sir, my question. Can you hear me?
No, I'll listen to you later.
Okay.
Please. Bhaskar was telling something. So can you please go ahead?
Yeah. Basically, my doubt was regarding the proportion. When it is inversely proportional, the M1 by M2 is R2 by root of R2 by root of R1, right? So when we write it as a ratio, will it be 1:2 or 2:1 was my doubt. So that's why I just wanted to clarify that. I just wanted you to revisit it. That's all.
Okay. So is it clear now?
Yeah. Now it is clear.
Okay, thanks a lot. Yeah, please, Raza, go ahead.
Thank you.
Yeah, welcome. Yeah, Raza, please go ahead.
Yes, sir. So my question is for the tokens, number of tokens. So it's not exactly number of words is equal to the number of tokens, because in ChatGPT they have tool where you can give the sentence and they will tell the number of tokens. And sometimes one token consists of more than one word. So that my question is. Can you clarify this?
Okay, Raza, can you please introduce yourself? So I have not talked to you previously.
Yeah. This I am joining this session first time, and I am a civil engineer and I live in Canada.
Okay, great. Yeah, thank you for joining. Yeah, so
welcome.
So the thing is that, so that's why this course is very necessary, this NLP course. So I have already told you that this NLP course is different from the language model course. We will not be learning how to build a ChatGPT here. Okay, we will be learning how to do this tokenization. Okay, so you have come up with a very interesting question. So you are saying that we have a sentence here that in Mumbai how many tokens are there or how many types are there, but ChatGPT is giving you a different answer, because the English is a language, but sometimes it is very hard to find out the tokens. That, so if you say PhD, some people write it like it, some people write it like it, or if you say doctor, some people write it like this, some people write it only DR. So, and also, so can you always say that this full stop means the end of your sentence? You can't say. So if you like PhD like this, then PhD is 2 tokens. Okay, token number 1 and token number 2, because you are calculating this dot as a end of your sentence, as end of your token. Or if you are calculating you have 2 conditions, you have increased your number of conditions. If there is a blank space, then you are saying that it is a token. Okay, so but the things are not that simple, and calculating this token are also very complex. It is more complex eventually when your language changes. Okay, so that's why they are using it depends on the ChatGPT is using some algorithm to calculate the number of tokens. We are in a very simple stage. We are seeing that by your hand, by your eye, how many token we can calculate. Then we eventually come up with the algorithm to calculate the token. We'll be saying that what is the stemming, what is the lemmatization to calculate, to find the root word and all. Okay, so am I able to answer your question? So my final answer is, the calculating the token, number of token is used here is different from it can be different from model to model. So if you give your Gemini model to calculate the number of tokens, then that can be different from the ChatGPT model. And also when you intuitively by your hand will calculate the number of token, that will be also different. So this is my final answer, because the algorithm they are using, that is different, and in subsequent classes we will be learning to how to calculate these tokens. So fine. So that's why I am not illustrating today to learn how to what are the algorithm used in calculating the tokens. But obviously in the Professor Poingoel's like that videos, you have seen something called decision tree. So decision tree is used to calculate the number of tokens. There are support vector machines. Support vector machines are used to calculate the number of tokens. Where in decision tree you use some if else condition to calculate the tokens. So you can refer to the video also that how to calculate the tokens. So is my answer clear to you? So so are you satisfied? So Raza, can you please speak up?
Yes, sir, you're right. Because different LLM use different algorithm to calculate the tokens, and also there are some like Python coding which can also assist for the calculating tokens.
Yeah.
So in simplistic way, it looks fine. Thank you.
Yeah. Thank you. Yeah. Thanks for asking. Yeah. Okay. Next we go ahead. We are running out of our time. Yeah. So this is the next question that we have to find that the TTR ratio, I think. So can you please write the answer in the chat box? So if anyone has a question in their mind, he or she can also write this in the chat box. So when I get time, I'll really reply to all of you. Okay. So okay, Devanshu is saying, that why cannot be TTR be 0? So I am also saying you that TTR can't be 1. Sorry, TTR can't be more than 1. So TTR, because that, like suppose you are saying a sentence, I am a good boy, all the words are unique. Okay, I unique, am unique, are unique, good unique, boy unique. So that's why here TTR type 2 token is like 7 by 7. Suppose there are 7 words, so that is unique. Okay, so and you are saying that why can't be TTR 0? So how can it be 0? There must be something. So like there must be all unique words or all unique type. So can you give me a situation, or can you give me an example where you are thinking that TTR will be 0?
0.075, 0.15 దేని ఎక్కువ ఉంటుందండి?
Hello.
Subhanu?
Yes, please.
Can I answer Devanshu?
Yes, please go ahead. It will be very helpful for me. Please.
Okay. See, basically TTR is the ratio between your types by the tokens, right?
Yes.
If at all the answer has to be 0, the denominator has to be numerator has to be 0.
Exactly.
And if numerator has to be 0, that means to say the types are 0. If types are 0, how will the number of words be greater than 0? It will also be 0. It will become indeterminate form.
Yes. And people has also given a very good answer. I have also not thought about this. They are saying that the corpus is empty. Okay. So
yeah. If the corpus is empty, then the type is 0 and the number of tokens will also be 0.
Yes.
It will become an indeterminate form.
Yes, exactly.
Then also it will not be 0.
Yes. Thanks.
0 by 0 will be indeterminate.
Yes, indefinite, yeah. So that's the answer. Thanks Oscar for sharing. Yeah.
Sir, I will disagree, because 0 upon 0 is not infinity is 0. 0 upon 0 is equal to 0. 0 upon 1 is equal to 0. 1 upon 0 is equal to infinity. So that's
0 upon anything will be 0, but 0 upon 0 is an indeterminate form. It is undefined.
Yes, 0 upon 0 is indeterminate. So we can't find anything. We can't divide anything with 0. So
0 upon any other value will be 0.
Yes, exactly. Yes, exactly. Okay, now we will come to this one. Give me a second. So come up with the thing that our question is if first corpus has TTR1 is equal to 0.075 and the second corpus has TTR2 is equal to 0.15, where TTR1 and TTR2 represent type token ratio in first and second corpus respectively, then which one is a correct answer basically. So first corpus has more tendency to use different word, second corpus has more tendency to use different word, both A and B, none of this. So type token ratio. Okay, so it's a simple question from the theory only. That means so basically which one is higher, TTR1 is higher or TTR2 is higher. So TTR2 is greater than TTR1. Okay, because 0.15 is greater than 0.075. Fine. So that's why second corpus has more tendency to use different word or use a unique word. So if TTR score is higher, then there is more tendency to use different word. Okay, so how can we see a example? So like I was referring to that example where this one this one this one, yeah. So here if I change it to we, so if I now in this slide I will write with yellow. So if I change it to we, then it will be 14/14, so that's why 1. Okay, if I change it to I previously, so it will be 14/13. Okay, so that's why sorry 13/14, so it will be less than 0. So 1 means ones mean higher value, 0.9 something means lower value. That means if TTR is high, there is a high chance of a unique word. Okay, so that is that if first corpus has the second corpus has more tendency to use different word because its TTR2 is high. Got it? Got the I give you an example, simple example. If you are following, I think this is clear from the example one. Yeah, please. Okay. Okay. Yeah, let's discuss that. Which of the following is are true for the English language? Yeah. So first thing is saying that lemmatization works only on inflectional morphemes and stemming works only on derivational morphemes. Okay. The output of lemmatization and stemming for the same word might differ. Okay. Output of lemmatization are always real words, output of stemming are always real words. So this real words means that what I think they mean, that is a word which can be found in the dictionary. Okay, so this is a multiple select question, this is called MSQ. Okay, there are multiple option which is correct. Okay, so now we see that what stemming refers to. So stemming means that so in the analysis of this, yeah. So uh, so where so where we are basically. So let me give you the so yeah, so we are now in morphology section. Okay, so we are analyzing the morphology. So morphology means study of word structure. Okay, so we are now studying the structure of a word. So we are basically we want to determine the root of a word, from where the word came. So there are two methods of doing this. So this morphology give you the root word. Okay, and uh, this stemming and lemmatizations are the two algorithm to use this morphological analysis. Okay, so if you use this stemming and lemmatization algorithm, then you can find the root word of a current word. Okay, so what that stemming say? Stemming says that root word. So I'm giving you the definition in a very lame language, because I'm not giving a bookish definition. So how I remember basically, so that stemming means that root word which need to be a dictionary word, and root word need not sorry the root word in stemming need not to be a dictionary word. You just cut it down, like if there is ss es, you do it ss. So suppose if there is ing, you remove the ing. So if there is able, so remove able. So then you remove the able, and your root word will be remove only. Got it? So this is how we are doing the stemming, but this is not a correct use. Okay, so that's why we sometimes we lose the meaning of a word. Okay, so that's why there is another algorithm called lemmatization came into the picture. So this lemmatization always give you a word from the dictionary. Okay, now why we are so if I get a word from a dictionary, then why should I look into the steps? Why should I really care about the stemming? Why should I give him attention at least? Because the stemming is very fast. This is getting the attention because the stemming is very fast. Even though it is not giving you a real meaning, it is giving you the result very quickly. So that's why stemming came into the picture, even though it has not come from the actual word. So stemming usually refers to a crude heuristic process that chops off the end of the word. Are you getting it? So I gave you the example. It chops off the end of the word in the hope of achieving this goal correctly most of the time. Okay, so most of the time it succeeded, and often includes the removal of the derivational affixes. So it removed the derivational affix, or affix means like prefix or suffix. So lemmatization usually refer to doing things. Lemmatization usually refer to doing things properly with the use of a vocabulary or and morphological analysis of a word. Normally aiming to remove the inflectional endings only and to return the base or dictionary form of a word, which is known as the lemma. Okay, so lemmatization basically match something with your dictionary, to match the word which we want to evaluate with all of these dictionary word, it takes time. So that's why lemmatization is slow. Okay, now so the 2 and 3 is the correct answer, because the output of the lemmatization and stemming for the same word might differ, and output of lemmatization are always real words. Fine, so these 2 and 3 are the correct answer. Yeah. Okay, now come to this question. Hmm. Okay, so let's solve this. Yeah, so the question is an advantage of Porter stemmer over a full morphological parser. Okay, so first of all, that what is the Porter stemmer? Okay, so the stemmer is better justified from theoretical point of view. Okay, and which one is correct? Basically, the output of stemmer is always uh, uh, always a valid word. Okay, so what is the Porter stemmer algorithm? So Porter stemmer rule. So I think I have already told you this one. So this ss, there are some set of rules that ss goes reduces to, so some word which ends with sses reduces to ss, some word start with, sorry, ends with ies reduces to ss, which ends with s reduces to null, which ends with ing reduces to null. So this is the Porter stemmer rule. Okay. So an advantage of Porter stemmer over a full morphological parser is, the answer is the 3. The stemmer does not require a detailed lexicon to implement. What does that mean? So the Porter stemmer algorithm is process for removing suffixes from words in English. Okay. The Porter stemming algorithm was made on the assumption that we don't have a stem or dictionary. Lexicon means, so we have a new word here, so that is that lexicon, yeah, detailed lexicon. So stemmer does not require a detailed lexicon to implement. That means a dictionary to implement. Okay, lexicon means dictionary. So we do not have dictionary or lexicon, and that the purpose of the task is to improve information retrieval performance. Stemming algorithms are typically rule-based algorithm. You can view them as a heuristic process that sort of loops up the end of the word. So basically, so if I say I am a good boy, so stemming algorithm have some rule. So it goes like this. If it see a blank space, then it will give you a algorithm or stemming algorithm. Okay, then you stem it and give you the root word like this. Then it will go like this. So this is a, you can view them as a heuristic process that sort of loops of them end of the word. So it start from here and end it here. Okay, like that. Yeah. So this is the thing. So now the next question. Yeah. Which of the following, yeah, which of the following are instances, which of the following are instances of stemming? Okay, which of the following are instances of stemming? As for Porter stemmer, so I think you have given the answer. So someone is saying 2. Okay, 2. So place, play. So yes, so we have already seen that if this is start with S, it is 5. Yes, right. So 2 is the right answer. Yes. Oh, okay, sorry. So you have, so Bhaskar, I was just looking to you, but I also forget about this one. So this is ITY. So ITY, so if ING or ITY, this will also come up with 5. So this universe is also right answer. Okay, so that's why. So stemming cannot convert R to B, as it only convert or chop up word suffixes, so it can only cut it down. Okay, also Porter stemmer would not chop off if the final outcome is of length 1, as in saw. Okay, so it will not chop off it. Okay, so so if the last word it is 1, it will not chop off this one. So that's why this is not our answer. Got it? So this is the thing. Okay, now next question. What is natural language processing good for? This is a general question only. Yeah. So we have a 2 answer correct here. One is 2, one is 4. Okay. Yeah. So now another is, what is natural language processing good for? Yeah. Summarizes block text, automatically generate keyword, identifying the type of entity extracted, all of the above. So basically they are asking about the work of like what you can do with your natural language processing task. So you can summarize block of text, I can automatically generate keyword, I can identify the type of extra. So I think all of the above is answer. Let's see. Yeah, all of the above answer. Yeah, now this is our last question of today's class. So what is the size of unique word in a document? The total number of words is 12,000 and k is 3.71 and beta is 0.69. So there we have to use a law here. We have to use yeah, that is called, yeah, got it. So this law is corresponding to how does the size of vocabulary grow with the size of corpus. Okay, so what are the number of tokens and what are the size of vocabulary? So for you to, yes, some of you are giving the option already. So maybe you are right. So my goal here is to why this question exists. So this exists because how does the size of vocabulary grow with size of corpus? Okay, so the thing is that we have the formula is not v is equal to k into n to the power beta. So our beta value is given 0.69 and k is 3.71. So this number of beta is size of vocabulary, and then n is number of tokens. Now your job, I give you the access of microphone. Okay, yes, please.
Subhanu,
Yes,
the
please.
previous question regarding the Porter's algorithm.
Go ahead.
Yeah, here answer, how is it 2 and 4? It must be just 2, right?
Oh, okay. So there is a, if there is a ITY, you cannot. So there are many rules are there. Okay, so that's why you can refer to internet or refer to Professor Porngo's that thing that.
No, I referred that.
Yeah.
IES will lead to I. ITY also leads to I. So if
No.
at all chopping has to be done, then I would have got UNIVERSI.
No.
In option 4.
ITY will go to 5, I think.
Is it?
I think so. I think it will go to 5. So these are the rule-based things. See, so
like, no, maybe I have copied it wrongly. I have copied it as, when I was making notes, I have made it as ITY and IES takes it to I.
Yeah. So what I remember that it will be 5. So see, I also don't remember because people don't remember this thing. So people remember this because of their exams. So I'm not also giving the exam. So I also forgot. I also, if this is a problem, really, I'll go back and I'll check, and if there is a change in the answer, I'll let you know in the next class. Okay? Is this solution?
No need. I'll just Google it in a minute.
Yeah, sure. Thanks a lot. Yeah. Okay. So let's come to our question. Okay, I think we have, yes. So yeah. So what the Heaps law says that, yes. So this is the law that some people has already answered this. Yes, 3.71 into 12,000 and root over 0.69 into 2421. So this was the law. So this is k and this is n to the power beta. Okay, that's why beta is this is, so this is beta basically. So this is, so I'm saying, so this is k is given, n is given, beta is given, and you have to find out v. Okay, so this is the Heaps law. This is a simple calculation only. Yeah. It seems the questions, Raja Ali says that, yes, Raja, let's plug the given formula into. Yes, Raja, you are very right that you just have to given formula and plug in. So I think this was all from my side for today's class. So if anyone has any suggestion, please give me their whatever their view for this course, and please, can you please like, are you satisfied how I go, like how the these 2 hours how I spent? Do you like this, or do you need some modification of this approach? So can you please suggest me?
It was actually basically very good.
Yeah, thanks a lot.
It was quite informative as well.
Yeah, thanks a lot. I'll try to come up with such information. Yeah.
Okay, thank you.
Yeah, thanks a lot. Yeah. So who someone is saying yes. So we have like it's a 2 hour session, and I have ended it 5 minutes earlier. So can anyone of you can introduce yourself? So like I am very surprised to see that there are all working professionals here. So I am not finding any student early. So where are the students? So can you anyone please like there are someone is commenting that Palak Tiwari and Bobita Sarangthem. So can you please introduce yourself? Where are you from? Uh, as I am telling that I am a PhD scholar and a PMRF scholar from IIT Delhi. So basically my research focuses on graph neural network, their training and all, and I also work with a okay. I'm not go ahead. Okay, fine. So this is my basic background. Yeah. So it's a recording session. I should not say much. Yeah. So can you guys please introduce yourself? Like there is Palak, Bobita, Pradeep. Yeah.
Good evening, sir.
Yeah, good evening. Good evening. Yeah.
I'm Palak Tiwari, and
Yes.
I'm a final year student at NIT Bhopal.
Okay. Okay.
And this is a part of my UG curriculum,
Mm-hmm.
so I had to attend this NLP class.
UG curriculum means so you have to do a NPTL class as a part of your.
Yeah. We have to do two NPTL courses, each of 12 weeks.
Okay.
So
Okay. Great.
that
Great.
the credit will transfer later on to our college, because we are currently on internship.
Okay.
Like we have taken NOC from our college
Mm-hmm.
and
In
managed
which
Bhopal.
company you are doing your internship?
I'm in Yash Technologies, Indore.
Yes, technology indoor. Yes, I know about this company. Yeah, I got it. Yeah, thanks for thanks for sharing. Yeah. Anyone else?
Thank you.
Anyone else?
Yeah.
Hmm. Okay, fine, fine. There are some technical glitches coming out. Okay, fine. Thank you everyone for joining. Yeah, you are doing PhD in sentiment analysis, so join NLP. Thank you. I'll try my best to give you some fruitful discussion out of this lecture. Okay, thanks for joining. So I am ending this session here. Okay, so we will meet in next week. Okay, fine. Thanks for joining everyone.